Hi, I'm Taylor DiClemente. I pluck strings. I have a classical guitar degree, bachelor's. I have a master's and I'm working on a doctorate in the European lute and the historical performance of plucked string instruments and their music from the 16th century through the 18th. I'm not a scholar, I'm a performer on the practical end of things. My training is Eurocentric, but my interests are global. And should the SETI satellites ever pick up anything compelling from elsewhere, I'd probably be interested in that too. I want to talk about what Western music has been doing for a long time and is still doing. And by Western, I am speaking very generally about the music from Europe since the Middle Ages and its colonizations, its spreadings, its tradings with the rest of the world. And we live in a global world now, but musically, so much of it, at least in popular styles, is westernized. I'm talking about music that is harmonic in nature, that has multiple voices or lines on instruments, moving in different paths, going through chord changes or harmonic progressions, and returning at the end of the piece to where it began. Most music around the world starts and ends at the same place, but most of it is melodic, and this harmonic nature is not unique to Europe in its music, but Europeans have focused on that dimension of it for, let's say, since the 12th century, but I'm being general. Um, T.S. Eliot said, "We will not cease from exploration, and the end of our exploring will be to arrive where we began and know it for the first time." That's the trip. That's what music does. But I want to talk about an elephant in the room in harmonic music, in Western music, in Westernized music, um, that exists with the math, with the ratios, the proportions of the intervals of the harmonies. Um, it's something a lot of people don't know about it, and it's something that people who do know about wish they didn't. Um, the way ancient Mesopotamians tuned a scale was by deriving naturally occurring ratios from what's called the harmonic series. If you hear the wind rustling in the leaves, or if you play harmonics up and down a guitar string, or if you play a bugle without valves, that's the series of pitches up and down the naturally occurring infinite harmonic series. So what happens is you have a frequency, goes up, goes down. Um, let's say you play a note on any instrument at 100 hertz. This is the main vibration of the note. We call it the fundamental vibration. But actually, an infinite number of secondary vibrations above it are sounding together, and the unique combination of those harmonics, as they're called, produce a unique timbre, a unique sound quality um, for for each instrument or each voice. That's how we can tell them apart. Their signature is in the combination of notes. Otherwise, if any instrument or any singer played the same note, they'd all sound the same if it were all just fundamentals. So we play one at 100 hertz, and then there is a second harmonic, first harmonic, second. This one is an octave above at double the frequency at 200 hertz. That's a 2-to-1 ratio. And then there's a 2-to-1 ratio, and then there's a 3-to-2 ratio. That's a perfect fifth above the 2. So you've got an octave and then a perfect fifth. and a perfect fourth that's 4 to 3, and it keeps going in smaller increments ad infinitum. So 1 or 1 to 1, 2 to 1, 3 to 2, 4 to 3, 5 to 4, 6 to 5. It keeps going infinitely, and they keep getting smaller and quieter. So we only hear the first couple. And while different cultures around the world use different scales and derive them differently, ultimately what nature has to say about music is this harmonic series. And most, not all cultures, but most of them recognize the first few audible pitches in the harmonic series and base their scales on them. I'll use a metric that Westerners are familiar with to illustrate. From what I understand, two cultures arrived at this independently, the Mesopotamian and the Chinese. And I'm not sure about the dates, but it doesn't matter. This is a clock, but let's pretend it is the circle of fifths, which is a map of pitches that Western musicians use. Basically, if we take a 3 to 2 perfect fifth and we stack a bunch of them together, then we take those pitches and put them together and we form a scale. So let's say this is C, and this is a circle of different pitches in increments of 5. So C, D, E, F, G. So 1 o'clock is G, and then 2 o'clock G, A, B, C, D. That's D, and it keeps going by perfect fifth. And I'm just using note names. I'm not talking about smaller intervals than that. This is a diatonic scale, diatonos, through the tones. What it means, or what it meant in its original sense, was a scale that was built by stacking fifths in this way. And Pythagoras figured out something about this that was curious and frustrating. If you start at C and you stack fifths all the way around, here's what happens. I'll go through it. C to G, D, A, E, B, F sharp. At this point, people usually switch to flats when they keep going, but I'm just going to, for the sake of simplicity, continue with sharps. So F sharp, C sharp, G sharp, D sharp, A sharp, E sharp, B sharp. You would think that you start at 12, you go all the way back to 12. The initial C and the final B sharp would be the same. But if you are tuning with these 3 to 2 perfect fifth intervals, perfectly in tune, that B sharp comes out a tiny bit sharp of the initial C. It comes out to about 1201. And if we were to go another lap, starting at 1201 with that B sharp, it'd be at 1202. And it just keeps going infinitely in a coil. So this elephant in the room that I'm talking about is that the circle of fifths, of which we are all comfortable and familiar, hopefully, is not real. It is, but it's an artifice. Really, the natural pattern is an infinite coil of fifths, right? Or it can be fourths going in the other direction. They're reversal. It doesn't matter. Pythagoras supposedly hid this discovery from his followers because he was so perturbed by it. And over the centuries, people, music theorists, instrument builders, organ builders, choristers, they've tried to figure out how to deal with it and have arrived at different conclusions and methods. But basically, if you have a piano and you want to tune it purely, perfectly, you can do it in one key. You can make it so C major sounds perfectly in tune But then if you were to play in another key, it would sound out. And like if C's here, um, these top few keys would sound pretty good, but as you move toward the bottom, they would sound worse. And at the nadir of F sharp, it would just sound horrible. So um, you can only tune purely in reference to one pitch. It is a mathematical impossibility to tune a piano so that it sounds purely in tune in every key. This is a grail quest. People want to, and we can't do it. So what happened in okay in medieval Europe, and I believe in the medieval Arabic world, which was kind of a parent tradition to the European. It was kind of a father-child relationship of culture flow. Um, the decision was to just use this pure intervals, but don't go all the way around. Nic plus ultra. Don't don't hang out down here. Hang out up here. Um, Chinese classical music. I don't know how ancient. It does the same thing. It tunes purely tunes to pure fifths, but just it ignores the overlap. So here's what happens. If you go all the way around, and then instead of going to 1201, if you just start over back at 12, then all these fifths will be pure except this final one, and it'll be too short, it'll sound bad, it'll be too small, and we call it a wolf fifth in the West. I don't know what Chinese musicians call it, but it's the same thing. They place it in a different spot, but basically both systems don't use it. And I believe medieval Arabic music did not either, but that's outside of my knowledge. One moment. So what you can just hang out in the top half of the circle and sound pretty good, or like the narrower space you take up, the fewer notes you sing. In other words, the closer to C you hang out, the more purely you remain. The Indian classical music tradition, North and South, Hindustani, Carnatic, does not change harmonies. It just stays put. It's a melody over a drone. The drone parks at C. They don't call it C, but it doesn't matter. And the melody dances around it. So they just never leave home. And as a result, the music is pure. They bend pitches and deviate from the pure interval and play with it. And that's the grace, the dance of it. But theoretically, it is founded in these naturally occurring super particular ratios of the harmonic series. But European music took a turn in, I want to say, the 14th century with an English composer named John Dunstable. He was a choral composer and a singer. This was sacred vocal music in church, with multiple voices singing independent lines. Polyphony, we call it. Polyphonia, multiple sounds. He started enjoying the consonant interval of the major third, which is 5-4 on that rising harmonic series. But the problem is when you start putting consonant thirds in your chords, so to speak, in your relations between the choral voices, the pitch standard, the reference pitch deviates slightly in the whole piece. So if you start at 100 hertz, that's arbitrary, and you go through the changes, and these changes involve thirds as major parts of the harmony, it's going to shift a little bit by intervals, by increments of that um, that little gap from 12 to 1201, which we call the Pythagorean comma. A comma just means an interval. So this little microtonal, barely perceptible but theoretical thorn in the paw of the music. These add up. And what happens is, if you're singing a cappella with no instrumental accompaniment, you start on a C and then you end on a C that's a little bit off, a little bit higher, a little bit lower. Does anybody notice? Probably not, but the theorists notice and know better, right? This comes about when you bring 5 to 4 thirds into the mix. It's complicated why, but there are papers written on it. Ask me in the comments. I'll direct you further. What did the instrumentalists do? What did the keyboardists do? They only had a set number of pitches. They didn't want like an infinite number of keys on their keyboards so that they could keep moving purely along this infinite spiral of theoretical pitches. They had to construct mathematical compromises. And some person in the 15th century figured out that if you take that Pythagorean comma, that little sliver 12 to 1201, and you divide it up into even smaller parts like fourths, and then you disperse them through some of these fifths at the top of this circle. Then what happens is you shrink those fifths by a fourth of a comma, but that brings the thirds in tune. Because if you tune by fifths, the thirds are too big. They're not 5/4 thirds that sound sweet. They're bigger and they sound nasty. So before that, like medieval music just treated them as dissonances and didn't focus on them. But John Dunstable and then the keyboardists who tried to adapt to his style of music, they had to construct these compromise tuning systems. That's called mean tone, specifically quarter comma mean tone, and it was de rigueur 15th, 16th century, and then variations of it kept going into the 19th. You can divide the comma up into different slices, and some of them are more subtle changes than others, but it's the same idea. So, learned musicians knew that they were making mathematical compromises and that their music was not pure. I'm not a moralist. I'm not going to say that it is, just or unjust, right or wrong. I'm not a priest. I'm not going to say what praises God and what displeases Him or whatever. But the fact is, if you mess with these intervals, you are deviating from the naturally occurring harmonic series, which is just one of those recurring patterns in nature of maximal efficiency that shows up again and again, kind of like phi, the golden ratio. So what people have been doing in the West, actually China did it first, much earlier, like with most things, is coming up with different systems of compromise to tune instruments of fixed pitches, of limited fixed pitches. We've got 12 notes per octave, and then pardon me, my video cuts off after a minute on my phone. So one can compromise by reducing an infinite pattern into a finite one and crimp the coil into a circle. There are other ways to do it. This one was posited in the 16th century, but not widely adopted until into the 19th. Now it is standard, called equal temperament, specifically 12-tone equal temperament. That is the Western standard and pretty much the global one, I have to say. There are other holdouts around the world, but it's just as most of the internet speaks English, most of the musical world and most of the modern instrument makers operate in 12-tone equal temperament. What that does is it divides this comma into 12 equal slices and distributes them equally across the circle. That is, it detunes each of these fifths by 1/12 of a comma. So everything is equally out of tune. A modern instrument like a guitar or a piano, like a Western harmonic instrument, with fixed pitches and a set number of them, is equally out of tune in all keys. And whether that is a beautiful or a horrible thing is, up to one's own discretion. I'm not a moralist, but that's the elephant in the room. That's the thorn in the paw, and people have been fussing over this since the days of Pythagoras. And there's no answer. It's a mathematical impossibility to do otherwise. So what are we going to do? That's what has been going on in the West. India classically is just hanging out in one spot, sounding beautiful and not deviating. Other cultures come up with compromises between these two extremes. John Coltrane found beauty in this system of equal temperament, and he would trace these geometries like an equilateral triangle, or a diamond, or a cross, and he would find beauty in the simplicity. To me, that sounds like the ancient Greek ideal of everything being in moderation. Like everything's out of tune a little bit. Pardon the analogy, but it's like being on antidepressant medicine. It takes the highs and the lows, and it compresses them into something homogeneous. And it's like fast food. That's my opinion. And then like going off the meds, going back to just intonation, as it's called, pure tuning, opens everything back up. So yeah, you can hang out in one space and play purely, or you can move everywhere like Coltrane, out of tune. Or you can play in mean tone, which is a compromise, where the top half of the circle sounds pretty good and the bottom half sounds really bad, and you just hang out in the upper half. So everybody's been asking this, everybody in the harmonic tradition has been asking the question, how can we tune our instruments maximally efficiently to be minimally out of tune for the music we're trying to make, right? What's the most efficient compromise system? What's the best way to cut corners? To me, I'm not like Coltrane. I find no beauty in that. I'm a purist. I want purity, and I'll be honest. I feel a little guilty playing, more than a little guilty. I feel guilty playing music that is fundamentally based on the idea of temperament. What do I mean by fundamental? I'll set up two subtle shadings of this idea. There is fundamental theory, and then there's instrumental practice, right? Theory is, the rules of the chess game you're playing. If you write music that follows a certain number of theoretical rules, and these rules are based on the idea that C and B sharp are the same, then you're going to inevitably produce a product that is influenced by that idea. If you don't, if you stay pure, and compose music that is based on, if you compose music that is based on the chess rules of the infinite coil, fine. But then if you want to perform it on a limited physical instrument, human tool with fixed pitches, like a guitar or something, then you're going to have to come up with a practical compromise. So that's the difference between theory and practice. Personally, I don't mind much playing on an imperfect instrument, but I mind very much about the theory, the music that I'm trying to compose and play. And it bugs me when the theory relies on tempered intervals. So what I am asking is, what are we doing, and who is looking this elephant in the eye? and trying to come up with a different game? Who is saying how can we compose with the coil instead of the circle? When most people, at least in this harmonic tradition, are busy either oblivious of the concept and the discrepancy in the impossibility of playing in tune, or is busy trying to crimp the coil into a circle. So now I have polluted your minds with this cognito hazard, this thorn in Pythagoras' paw, and you can thank me or curse me in the comments. Take care.